This is a titan of the forest, a living giant that has stood for centuries. Its rings hold the memory of seasons, storms, and silence. It weighs tens of thousands of pounds, a colossal column of raw, untamed nature. And this is what it's destined to become. A surface so flawless it feels like liquid silk. A piece of functional art, holding a story that began long before any of us were born. Most people see a tree, others see lumber. But today, we see a masterpiece in waiting. We are going inside a colossal mega factory, a place where impossible scale meets microscopic precision, to witness one of the most incredible transformations on Earth. We'll follow a massive hardwood titan from the moment it arrives, through roaring saws and intelligent robots, to the moment it becomes a piece of luxury furniture worth tens or even hundreds of thousands of dollars. This is the story of how some of Earth's most impressive trees are reborn. Chapter 1. The arrival of a titan. The journey doesn't begin in the pristine, quiet halls of a design studio. It begins here, with the rumble of a diesel engine and the groan of a specialized, extended-length trailer navigating the final turn into the factory compound. The log arrives not just as wood, but as a geological event. It's often so overwhelmingly massive that it dwarfs the very machinery designed to handle it. These aren't just any logs. They are salvaged giants, massive trees from managed forests, or colossal timbers reclaimed from structures of a bygone era. Their sheer scale presents the first and arguably one of the greatest logistical challenges. Imagine trying to move an object the weight of a city bus, but with none of the convenient wheels or lifting points. Here, that challenge is met with a symphony of heavy engineering. A massive gantry crane, its steel sinews capable of lifting over 50 tons, slowly hums to life. Thick steel cables as wide as a person's forearm are carefully slung around the log. The crane operator, sitting in a glass box high above, doesn't just lift, they balance. A slight miscalculation, an uneven lift, and thousands of pounds of unstable timber could come crashing down. A catastrophe. With agonizing slowness, the log is hoisted into the air, its immense weight silencing the yard. For a moment, it hangs suspended, a leviathan between earth and sky, before being gently lowered onto a custom-built conveyor system. These aren't your simple roller belts. They're chains of reinforced steel set into a concrete channel, powerful enough to drag the multi-ton giant toward the first stage of its deconstruction. The factory itself looms in the background, a sprawling complex of interconnected buildings, its scale dictated by the size of the raw material it must consume. Everything here is supersized, from the bay doors tall enough to admit a small building to the ventilation systems designed to process literal tons of sawdust. The arrival is a slow, deliberate, and awe-inspiring process. It's the factory's first handshake with the giant it's about to tame, a silent acknowledgement of the power and history locked inside the wood. Chapter 2. The First Cut. Revealing the soul within. Before the roar of the primary saws begins, a more delicate yet equally crucial process takes place. The log, now resting on an industrial steel cradle, is still wearing its thick, coarse armor of bark. This outer layer, the tree's protection for centuries, is useless for furniture. It's filled with dirt, rocks, and moisture that would dull even the toughest saw blades in an instant. So, the debarking process begins. In some operations, it's a brutally mechanical affair. A high-pressure water jet, firing a concentrated stream powerful enough to strip paint from steel, blasts along the length of the trunk, tearing away the bark and revealing the pale, naked wood underneath. In other, more advanced setups, a specialized machine with a rotating, cutting head peels the bark away in long, continuous strips, like peeling a gargantuan vegetable. It's messy, loud, and wet, but it's the first true moment of revelation. Once the bark is gone, the log is no longer just a log. It's a blank canvas. And now, the true artisans of the factory step forward. These are the master sawyers and lumber graders. They don't see a uniform cylinder of wood. They see a story written in grain. Walking the length of the massive trunk, their hands run over the surface, their eyes tracing the lines and swirls. They are reading the log's history to predict its future. Is that dark knot a potential weak point, or a stunning visual feature to highlight in the center of a tabletop? Does that subtle wave in the grain indicate tension that could cause the wood to warp? Where is the coveted, darker heartwood, and how can it be maximized? They are looking for the sapwood, the softer, paler wood from the outer layers, which is often trimmed away. They are assessing the log for any signs of rot, insect damage, or hidden stresses that could compromise the final product. This assessment is a blend of high-tech science and a deep, almost intuitive, understanding of wood. They might use ultrasound scanners to peer deep inside the log, mapping its internal density, but their final decisions often come down to decades of experience. Based on this assessment, they'll mark the log with chalk lines, indicating the path of the first cuts. These lines will determine everything. They'll decide whether the log becomes a series of thick, monolithic slabs for massive dining tables or is broken down into smaller, uniform boards for cabinets and chairs. An error here isn't just a mistake, it's the squandering of a century-old treasure. Chapter 3. The Megasaw, a battle of steel and timber. This is the heart of the factory, a cathedral of noise and power. In the center of a vast open hall stands the head rig, the primary sawmill, a machine of truly monumental proportions. Sometimes it's a colossal bandsaw, with a blade that is a continuous toothed ribbon of steel stretching over two giant wheels that can be stories tall. In other factories, it's a state-of-the-art CNC-guided saw, its circular blade several meters in diameter, poised on a robotic arm. The multi-ton log is moved into position, secured onto a carriage that looks like a small, flatbed train car. This carriage is the key to precision. It glides on perfectly machined rails, controlled by a computer system that can adjust its position by fractions of a millimeter. The sawyer, often sitting in a climate-controlled armored glass booth, is the conductor of this orchestra of destruction and creation. A deafening horn blast gives the warning. Then, with a scream that builds from a low hum to a piercing shriek, the megasaw spins to life. The blade becomes a silver blur, its thousands of teeth hungry for the first bite. The sawyer engages the carriage, and the icy giant log begins its slow, inexorable advance. The moment of contact is violent. The blade hits the ancient wood, and a volcano of sawdust erupts, instantly filling the air with the sharp, clean scent of oak or walnut. The sound is overwhelming, a deafening, high-frequency roar that vibrates through the concrete floor and into your bones. The saw doesn't just cut, it vaporizes a path through the log. The sawyer isn't just watching, they are making constant, micro-adjustments, monitoring the strain on the blade, listening to the pitch of the motor, and feeling the resistance of the wood. The computer follows the chalk lines, but the sawyer is the final arbiter. If they hear the blade begin to labor on a dense knot, they might slow the feed rate. If the wood starts to bind, they can back off and reapproach. They're in a constant, high-stakes dialogue with the material. This first cut, the opening face, can take several minutes to carve a perfectly flat plane along the log. The carriage retracts, the log is hydraulically rotated 90 degrees, and the process begins again. Slice after slice, the giant is methodically deconstructed. Each pass reveals a new secret, a new pattern of grain hidden just millimeters below. What was a round, natural form is transformed into squared-off cants and thick, rough-sawn slabs. A single giant log might yield the monolithic slab for a 15-foot conference table, along with dozens of matching boards for the chairs that will surround it, ensuring the grain and color are consistent across the entire set. This isn't just cutting wood, it's industrial-scale sculpture, releasing the geometric potential locked inside the organic form. Chapter 4. The Great Thirst, the slow and crucial science of drying. The freshly sawn slabs, dripping with sap and heavy with moisture, are now at their most vulnerable. A living tree can be more than 30% water by weight. If this moisture is removed too quickly, the wood will twist, crack, and warp into unusable shapes. Too slowly, and it can lead to mold and decay. The next stage is perhaps the least dramatic, yet the most critical for creating stable, heirloom-quality furniture: the drying process. This is a battle against time and the very nature of wood itself. The journey begins in the stacking yard. Here, under vast, open-sided shelters that protect the wood from direct rain and sun but allow for maximum airflow, the slabs are carefully stacked. But it's not a simple pile. Small, uniform pieces of wood called stickers are placed between each slab, creating consistent air gaps. This allows air to circulate evenly around every surface, promoting slow, gentle evaporation. For thick, valuable slabs from the heart of a giant tree, this air-drying stage is a profound exercise in patience. They may rest here for years. The rule of thumb for many hardwoods is 1 year of air drying for every inch of thickness. For a 4-inch thick slab of premium oak, that means 4 years in the yard, slowly acclimatizing and releasing the bulk of its internal moisture. During this time, the wood is periodically checked as nature does its work. This slow, initial phase reduces the moisture content from over 30% down to around 20%, but 20% is still far too moist for indoor furniture. The final, crucial stage takes place inside the kilns. These are not simple ovens. They are massive, building-sized chambers where every variable is precisely controlled. Many modern, sustainable factories now use solar kilns, which use the sun's energy to heat the air, or biomass kilns fueled by the sawdust and offcuts from the factory floor. Inside the kiln, the stacks of wood are subjected to a scientifically calibrated schedule of heat and humidity. A computer system, running a program specific to the wood species and thickness, slowly raises the temperature while carefully managing humidity. The goal is to draw moisture from the core of the wood to the surface, where it can evaporate, without creating stress. Too dry and the surface cracks. Too humid and the process risks mold. Large fans circulate the conditioned air, ensuring every board dries at the same rate. Sensors inside the kiln and even probes placed directly into the wood feed real-time data back to the control system. This process can take several more weeks or even months, aiming to bring the moisture content down to a stable 8 to 12%, the sweet spot for most indoor environments. This painstaking two-stage drying process ensures the final product will remain stable and beautiful for generations, not cracking or warping with the changing seasons in a client's home. Chapter 5. The Digital Sculptor, where precision meets raw beauty. After years of patient drying, the stabilized slabs enter the most technologically intense part of the factory. This is where raw rustic slabs are transformed into perfectly dimensioned and impossibly smooth components. It's the realm of the digital sculptor, the CNC machine. The process begins at a planing station. Slabs are fed into enormous industrial planers where massive rotating cutter heads, armed with rows of carbide knives, shave off a thin layer from each face. With a high-pitched whine, a board emerges that is perfectly flat and of a consistent thickness. This step reveals the wood's true grain and color, muted by the drying process. Automated optical scanners might grade the wood here, sorting boards for different product lines, while computer-guided rip saws trim away any remaining defects. Now, the slab is ready for the main event. It's moved on to the massive bed of a 5-axis CNC router, a machine the size of a small room and held firmly in place by a powerful vacuum. High above, a robotic gantry holds a high-speed cutting spindle. This is where the digital design, created by engineers miles away, finally meets the physical material. The operator loads the program, and the machine whirs to life. But unlike the brute force of the head rig, the CNC is a tool of almost surgical precision. Following the digital code, the router bit, spinning at tens of thousands of RPM, descends upon the wood. It can move along the X, Y, and Z axes, while the head itself tilts and rotates, allowing it to carve complex, three-dimensional shapes nearly impossible for a human to replicate by hand. We watch as it flawlessly cuts the perfect arc for a curved chair leg, or routes out intricate mortises for a complex joint, accurate to 1/1000th of an inch. For a large dining table, the CNC might be used to perfectly flatten the entire slab one final time, a process called surfacing. It glides back and forth across the entire width of the slab, creating a surface so flat you could use it as a reference for precision engineering. This phase is a mesmerizing dance of technology. There is no guesswork, no chalk lines. It is pure, repeatable precision. And yet, the result isn't a cold, sterile product. The perfection of the machine serves only to highlight the organic, unique beauty of the wood. The perfectly cut curve flows with the natural grain, and the impossibly flat surface reveals the depth and shimmer of the timber. The machine isn't replacing the craftsman. It's giving them a tool of unparalleled capability, allowing the natural art of the wood to be presented in its most perfect form. Seeing a digital path translated into a perfect form on a piece of wood that's hundreds of years old is simply breathtaking. It's the ultimate fusion of nature's artistry and human ingenuity. If you find this process as fascinating as we do and want to see more incredible transformations from inside the world's most advanced workshops, take a moment to hit that subscribe button and ring the bell. You won't want to miss what happens when these individual parts become a unified whole. Chapter 6. The Art of the Joint. A Symphony of Assembly. The factory floor now looks like a collection of perfectly sculpted puzzle pieces. We have flawless tabletops, elegant legs, and precisely cut cabinet doors. But they are not yet furniture. The next stage is assembly, where these parts are brought together to create a strong, stable, and seamless whole. This is where modern automation and timeless craftsmanship often work side by side. The joinery is what separates high-end, solid wood furniture from its mass-market counterparts. You won't find cheap screws or metal brackets here. The strength comes from the wood itself, shaped to lock together in ways that have been perfected over centuries. We see components being prepared for mortise and tenon joints, where a precisely cut tenon fits into a matching mortise on another piece. We see the interlocking fingers of dovetail joints, a hallmark of quality construction, often cut by specialized CNC jigs for a flawless fit. In the more automated sections, this process is a model of efficiency. Components move along a line to a gluing station where robotic arms apply a perfectly even layer of specialized wood glue. The pieces are then brought together and loaded into a large press that applies immense, uniform pressure, ensuring a rock-solid bond. But alongside this automation, you'll find bays of artisan assemblers, especially for custom pieces. Here, a single craftsman or a small team is responsible for the entire assembly. They work with the same CNC-cut components, but the final fit is done by hand. They might use a small hand plane to take a whisper-thin shaving off a tenon for a perfect friction set. They test the joints, feeling for any rock or play, ensuring the connection is seamless. They are the final quality control before the piece becomes one. For a cabinet, this means hanging the doors, ensuring the gap around them is perfectly uniform, no thicker than a credit card all the way around. This fusion of machine-made precision and hand-tuned assembly is key. The machines provide an accuracy beyond human capability, while the craftsman provides the nuance and the soul. Chapter 7. The Final Veil. The painstaking path to a perfect finish. The piece is now fully assembled. It has the form of a table or a cabinet. It's strong and structurally complete, but it lacks the final critical element that transforms it from an object into a piece of luxury. It lacks the finish. The surface, though smooth from the CNC, still bears the microscopic marks of the machine. It feels good, but it doesn't feel like silk. The color is there, but it lacks depth and vibrancy. The final finishing stage is a meticulous, multi-step process designed to appeal to our most sensitive faculty, the sense of touch. It all begins with sanding, and then more sanding. It's a laborious process that is absolutely essential for a high-end result. The process is progressive, starting with a relatively coarse 120 grit sandpaper to remove any machine marks and level the joints. After the first pass, the entire piece is cleaned of dust, and the process is repeated with a finer grit, maybe 180 or 220. With each successively finer grit, the scratches from the previous one are erased. This continues up through the grits, 320, 400, sometimes even higher. In the final stages, this sanding is often done by hand. A craftsman can feel imperfections the eye might miss. They aren't just smoothing the wood, they are polishing it to a surface that feels almost impossibly smooth. Once the sanding is complete, the piece is moved to a pristine, dust-free finishing room where the air is filtered. Now, the magic happens. A finisher applies the first coat, perhaps a natural oil that penetrates deep into the wood to bring out its natural color, or a durable hard wax oil for a satin luster. The application method varies. Oils are often worked into the wood by hand with soft cloths. For lacquers and varnishes, robotic spray arms in sealed booths often apply a perfectly atomized, micron-thin layer that a human hand could never match. But it's not over. After the first coat dries, the surface often feels slightly rough again. The liquid has caused tiny wood fibers to swell and stand up, a phenomenon called raising the grain. So the surface is lightly sanded again with an ultra-fine grit paper to shear off these raised fibers. Then a second coat is applied, and a third, and sometimes a fourth or fifth. Between each coat, there is more light sanding, more cleaning. This painstaking layering is what builds the depth, luster, and durability of the finish. It's what creates that liquid smooth feel and the deep, three-dimensional shimmer in the grain. This is the final veil, the last touch that elevates the raw material into a treasured object ready for a home. And this is the result. After a journey that spanned years, through the hands of dozens of experts and the jaws of multi-ton machines, the transformation is complete. What began as a colossal, rough-barked giant, a raw titan of the wilderness, now stands, reborn. Here it is. A monolithic dining table, its surface a single, unbroken expanse of solid black walnut, so polished it mirrors the light above. The story of its life, written in its grain, is now the centerpiece of a room where new stories will be told for generations. Here is a set of cabinets, their solid oak doors opening with a satisfying weight, the grain flowing perfectly from one door to the next, a testament to the foresight of the sawyer who first broke down the log. This process, a marriage of brute force and delicate finesse, of natural wonder and technological wizardry, is about more than just making furniture. It is an act of preservation. It takes the soul of the tree, its history and its beauty, and gives it a second life. It captures the carbon stored within the wood and locks it into a form that will be cherished and valued for a century or more. From a silent giant in a forgotten forest to a functional work of art, this is the final, breathtaking destination. It is a testament to the idea that with skill, technology, and a deep reverence for the material, we can transform the raw power of nature into timeless elegance.